All right, so we're talking about angle pair relationships. So the big picture here is we just talked about single angles, how to classify them, how to name them. Now we're going to talk about relationships between two or more angles. Specifically, we're mostly going to talk about pairs of relationships. So starting off, just to review a couple things so we're all on the same page. This is the symbol for a right angle. This little box inside of an angle means that an angle is a right angle or is 90 degrees in measure. Now, never assume just because something looks like a right angle that it is. That's a super common mistake. Okay? We would definitely put this symbol in there if we wanted you to know it was 90 degrees. Okay? And then if you have congruent angles, just to be really clear, we would use one of two ways to show you that. Basically, it would be the same thing here and the same thing here means they're the same angle. But more specifically, we'd have multiple arcs or just a single arc, but we'd have the same number of angle arcs on this angle as we have on this angle. So in this case, we have 2 arcs in each, meaning these two match. And then in the same picture, we could have 3 arcs and 3 arcs, 4 arcs and 4 arcs, and so on. That's a little more common in our book. However, in other geometry textbooks, they may use a single arc with a number of dashes. So here's an arc with 2 dashes, and that would match with the arc with 2 dashes. So either one of those symbols means that those are the same angles, or those angles are congruent. Okay. One more thing is, whenever you have one 90-degree angle, you actually have 4 90-degree angles. The reason is here, we know that a straight line makes 180 degrees, and the one assumption you can make in this whole first semester geometry is if a line looks straight, then it is straight. So we can assume this is a straight line. So if this is 180 degrees, and we already have 90 on one side, well then the leftover must be, I'll just do it in green here. If this is 180 total, well then 180 minus 90 over here, because the 90 is on the right, the leftover is another 90 degrees, and we get a right angle. Same logic with the next one. We'd say, oh, well, if the top to the bottom is 180 degrees, and we already have 90 on the top, well, then 180 minus 90, we must have 90 on the bottom. And similarly over here. So anytime you have a single right angle in a picture, you actually have 4 right angles. So anytime you see that red right angle, you know those 2 lines are perpendicular, so immediately you have 4 right angles. That can be really useful. Okay, so now that we're all on the same page, let's start. So our first vocab is adjacent. It's the same thing as in any other way you'd use it in the English language. You could say 2 students are adjacent if they're sitting next to each other. You could say 2 cars are adjacent if they're parked in parking spots right next to each other. Your house is adjacent to the next house. Now, specifically the way we use it with angles is adjacent doesn't just mean close to, it means exactly touching, sharing a side. And then I add this, they have to not be inside of one another, right? I wouldn't say my room is adjacent to my house because it's inside my house. Now, if it was a shed on the outside, sharing a wall with my house, I could say, oh yeah, my shed is adjacent to my house. It's not inside my house, but they are touching, they're sharing a wall. Okay, so right here what that looks like is this angle here is sharing BD with this angle over here. So since they both share BD, and this angle 1 and this angle 2 are next to each other and not overlapping or inside of one another, we'd say angle 1 and angle 2 are adjacent. Or here I say angle ABD, right? ABD and angle DBC are adjacent. Now over here I said angle M and angle N are not. Just to go even further with not inside one of another, if I draw an angle and then start along this same thing but go back inside, those 2 angles are not adjacent even though they share this right side, because they're inside of one another. Okay, just highlighting that. All right, that's our first word. 2 angles can be adjacent if they share a side. complementary and supplementary. Supplementary being especially common in this class. So complementary means two angles whose measures add up to 90 degrees. They do not have to be next to each other adjacent, but any two angles that add up to 90 degrees are complementary angles. Any two angles that add up to 180 degrees are supplementary angles. Okay, so I'm just going to give you a couple examples. Really trying to just highlight that a common assumption people make is just because they're supplementary, people assume they're adjacent, and that's not true. Okay, so let's look down here. So angles could be adjacent and complementary, right? So they, in this case, 20 plus 70 is 90 degrees, so they're complementary. And those two angles do share a side. So yeah, those are adjacent and complementary. And what that looks like is a right angle that's been split into two parts. It doesn't matter if it's split evenly or if it's split into 1 degree and 89, 1.73 degrees and the 88.37, like whatever its split is, it's a right angle that's split, that's complementary, and those two angles are adjacent. However, the two angles could still add up to 90 and not be adjacent, right? There's a 20-degree angle floating in, 3D space, and there's a 70-degree angle floating somewhere else in space, but they're not touching, they're not adjacent, so those are still complementary angles. Same thing with supplementary. Two angles could add up to 180 and be adjacent. In this case, we'll give those a special name, actually. That's their next vocab word. We'll come back to it. But supplementary angles don't have to be adjacent, right? They could just be this 140 and 40 down here in the bottom right. These are not adjacent, but they still add up to 180. They're still supplementary angles. Okay, so supplementary means they add up to 180. Now, this is an interesting one. If they're supplementary and they're adjacent, when you put those together, what they end up making is a straight line. Right? If they're next to each other and to the left and to the right, total opens up to 180 degrees, we end up getting a straight line every time. And in math, the word we use for a straight line is linear, right? When you graphed a y equals mx plus b and it was straight, we call that a linear function, right? We're going to use the word linear in math to mean a straight line. So down here, we're going to call this pair a linear pair because the pair makes a line. So a linear pair are two angles that are both adjacent and supplementary, just like up here. They're next to each other and they add up to 180. Or in other words, you could just say two angles that make a straight line. Now that's not a geometric definition, that's just a good way to remember it. But here's a linear pair, right? 30 plus 150 adds up to 180 and they're adjacent. So we do get, we do get a straight line here. Now, these other ones over here, these are supplementary, but since they're not adjacent, we don't get a straight line anywhere, so these are not a linear pair. Now, I always like giving a yes example and a no example. I think that helps separate and say, like, here is an example of it, and here's what, is not true, and you're like, oh, I see the difference. Okay? So our last vocab word are vertical angles. Now, the first definition is a more geometric definition. Two angles formed by pairs of opposite rays. Opposite rays, remember, are starting at a point, and then in any direction goes the first ray, and the opposite ray is exactly starting at that same point, but going in the opposite direction, 180 degrees in the other direction. Right? So, if we say took an angle, I was just explaining what this definition means, if we took an angle formed by a point and two rays, and we said, well, let's look at the opposite ray of this one, and then let's look at the other opposite ray of the other side of the angle, you get these are vertical angles. However, I like just thinking about it in much simpler terms as the two opposite angles formed where two lines cross. So if this line crosses another line, then the opposite angles, these two green ones, are vertical angles. And these red ones are opposite also, so that's another pair of vertical angles. So you always get two pairs. Okay, so just be really clear, the two red angles are a pair of vertical angles, and the two green angles are a pair of vertical angles. Probably one of the most useful things we'll use throughout these chapters is vertical angles are always congruent. when we get to chapter 2 in logic, we're going to actually prove that step by step, but I'll just do a little reasoning why, okay? Another one of the biggest things to take away from this chapter is if two lines cross and you know a single angle about where and how they cross, then you know everything about that intersection, okay? And let's see. So we can assume anything that looks like a straight line is a straight line. So your one assumption. So I know that this must be 180 degrees, straight line, right? I was facing it one way, and I did a full 180, and now I'm facing the other way, okay? So if that's 180 degrees, well, then I'm just going to say, well, then this must be 180 minus the 30 I know, so the leftover is 150 degrees, right? But I could do the exact same thing on the other side. So if I erase this and say, okay, well, I also know that this is a straight line, 180 degrees, and if I have 30 already, well, then this must be the same 180 minus the same 30, so of course I'll get the same 150. So it's a very informal, we didn't use variables, that was just a one anecdotal example, but that's the way we're going to prove it later. But it is obvious that if that's 30 right here, and we take that away from 180 here, and we take it away from 180 here, we'll always get the same number on the left and the right. So those vertical angles will always match. And then even to go one step further, if this is 180, and we already know 50, well then the leftover is 180 minus 150, or 30 degrees. So that pair will also match. So as soon as we know one angle, right, if these cross and this is 125 degrees, we go, well, this is the same. And then its counterpart is 180 minus the 125 we know. So that's 55 and 55. So just knowing one angle at an intersection means we know every angle at the intersection. All right, so let's just go through a bunch of examples now. That was the new lesson. All right, so first, tell whether the indicated angles are adjacent. So let's look. We've got ABD and DBC. Yes, they share BD and they're not inside one another. WXY and XYZ, no. They're close to each other, they're nearby. We'll actually, later on, we'll call these consecutive angles. You don't need to know about that yet. But when we're talking about polygons, consecutive angles means the next one, right? Like the next consecutive number after 3 is 4. Just consecutive means the one immediately following. But again, the answer here is just no. Okay. LQM and NQM, yes, those are adjacent. Okay. Name a pair of complementary angles and a pair of supplementary angles. Let's see. So, we want something that adds up to 90. That's complementary. And we want something that adds up to 180. That's supplementary. So our complementary pair is, let's see, we got angle STR, that's 60 degrees, and angle VWU, which is 30, because 60 plus 30 equals 90. Great. And our supplementary pair are, let's see, that's angle QTS, which its measure is 150 degrees, and angle VWU, which is 30 degrees, and that's because when you add those up, they're 180, so those are supplementary, okay? And we're going to skip 7, just, same sort of problem. Okay, the one thing here, though, actually, let's just talk about number 7. So if we want to name a complementary pair, we know because this is a right angle, and there's 180 total, we know this is also a right angle, because there's a leftover 90 degrees there. Okay, so our two complementary angles would be this angle and this angle. And then if we want to name two supplementary angles, we have a lot of options there. So I'm going to erase this. Those would be my two complementary angles. Now for supplementary, we could do a couple. We could either do in purple this angle and this angle, those two add up to 180. Or in green, we could do this angle and this angle. Two right angles would also be supplementary. So a couple options there. I just want to talk about it. I didn't write out the angle names. Okay, so angle 1 and angle 2 are complementary angles. Given the measure of angle 1, find the measure of angle 2. Well, the measure of angle 2 is going to be the leftover from the 90, so it's going to be 90 minus the 43 we already know. So it's going to be 47 degrees, right? And the rest are going to be the same, so we don't need to go through all those. In the next one, we have two angles are supplementary. So if we're given the measure of angle 1, what's the measure of angle 2? Well, we know the measure of angle 1 plus the measure of angle 2 adds up to 180 degrees. So the leftover measure of angle 2 must be just the total 180 minus the 155 we already have. So that's going to be the measure of angle 2 is 25 degrees. Perfect. Okay, again, all the rest here are the same, so we're just going to skip through those. So find the measure of angle DEG and measure of angle GEF. Now, this is where we start to see that the first step in a problem is geometry, and then the rest after that is algebra. So most of these problems are the same, or at least 17 and 18, so I'm just going to erase 18. We don't need to do both. That'd be redundant. We could do 17 and 19, though. So let's do the first one. So what's the relationship here between this angle and this angle? Well, I see that they make a straight line, and so I know they're not only supplementary and adjacent, but we call those a linear pair because they make a line. So I know their relationship is they add up to be 180 degrees. So I'm going to write 18x minus 9. You don't need the parentheses. I kind of just do an underline just to say that's a group. But if you want parentheses, great. Plus, and the reason we don't need parentheses is because we're just adding them, right? If we were subtracting, we would need parentheses. 4x plus 13, and that's equal to a total of 180 degrees. Okay, so I'm just going to solve this normal algebra. So combine like terms, combining like terms still, 180, subtracting 4, 22x equals 176. Divide by 22 on both sides. We get x's, that's going to be 8. Now we need to see what it's asking. It says, find the measure of angle DEG, the left one, and GEF, the right one. So we need to go back and plug these in. Okay, so the left angle, DEG, 18x minus 9 becomes 18 times 8 minus 9. That's 80 and 64, so that's 144. Minus 9, or 135. Subtracting my 9 is always hard for me. Okay, and then plug into left one, or right one. We get 4 times 8 plus 13, 32 plus 13, that's 45. And just to double check that those add up to 180, 135 plus 45 equals 180. Good, it worked out in the end. So our two angles are 135 and 45. Over here, I'll just set this up. We notice that, let's do it in green, this is 90 degrees, and if this total is 180, well, then this other one must also be 90, just 180 minus 90. So our relationship between this angle and this angle is that they're complementary. 6x plus 4x equals 90 degrees, and then, oh shoot, it's so quick to solve, let's just do it. Dividing by 10. We get x is 9. Again, it's asking for two separate angles, DEG and GEF, so we plug it back in. 6x becomes 54 degrees. 4x becomes 36 degrees. And adding those together, we do get 90, which checks out. So those are our two angles we were looking for. Okay. So here we're just going to tell the relationship between these. So I'll just use a V for vertical angles and L, or let's call it VA for vertical angles, LP for linear pair, or N for neither. Okay? So let's look at these angles. I'm just going to use, let's use pink and I'll just erase it. So 1 and 4. 1 and 4 are across from each other where two things meet. So these are vertical angles. Okay, erasing that. 3 and 5 are nothing to do. All of our relationships have to do with a single intersection. So they are not a linear pair. They're not vertical angles. So we're going to erase that. They're not even in the same intersection. That's what all of chapter 3 is about, actually, is how to relate things that are at different intersections, which is super fun. One of my favorite chapters. So anyways, back to this. So this was neither. Okay, 7, 8, 9. Oh my goodness. So all of those do add up. This is an interesting one. Now I had a student ask me, great question, could you say that more than two things are supplementary angles? And I'll say, not by the rigorous definition, although I'd accept it. You could extend the definition to say a linear group of angles, or a group of angles that add up to 180 degrees. However, they're definitely not a linear pair. I mean, pair in the word says pair. There are two of them, so they are definitely not a linear pair. So here we would say these are not a linear pair or vertical angles. And then go back, we'll go 6 and 7. 6 and 7, not even at the same intersection, so neither. 21, 1 and 2, those do make a straight line. So those are a linear pair. 2 and 3, I'm just going to erase all this crazy work I've done. 2 and 3 are across from each other where two lines meet, so these are vertical angles. 5 and 6, those make a straight line, so that's a linear pair. And then 5 and 9 aren't even at the same intersection, so they have no relationship yet. We'll get to relationships of those later. Oh, so cool. Okay. So last problems we're going to do here, and then I'll just jump on to IXL for a few examples, just clicking through a vocabulary. But this is a really common type of problem here. So we want to solve for both x and y. The key here is I don't want to set up a relationship between x's and y's, because then I need a system of equations, right? Two variables in one equation, then I'm going to need x's and y's and x's and y's and something, something. Instead, what I really would like to do is write one equation with one variable from the get-go. So although I could say vertical angles are congruent, so 2y equals 7x, I don't want to start there. I would like, if I can, to start with one equation that has just one variable. So let's re-look at this and cleverly say, oh, well, here's something with x's and here's something with x's. Do we have a relationship between those two? Because I'd prefer a relationship between those. Oh, you know what we do? They're a linear pair. They add up to 180 degrees. They're both adjacent and supplementary, so they're a linear pair making that straight line. So we go, okay, well, one of them plus the other one is going to add up to a total of 180 degrees. So we get 16x plus 20, just combining like terms, is 180. And then solving, we get 16x equals 160. Dividing by 16, we get x equals 10. Again, let's look at what it wanted. Oh, it wanted the values of x and y, so we're halfway done. There's x. And now if we want to find y, I go back to the original drawing and I plug it in and see what the values are. Now, I know you could set up an equation with x's and y's, but we just solved for x. We don't need x's anymore. I could cross this out and say, no, 7 times 10, this is just 70 degrees. I don't need any more x's in my diagram. I'd prefer not to have that. So this becomes 90 plus 20, or 110 degrees. So this is 110, and this over here is 70. I have two options here. I could just say, well, vertical angles are congruent, so 2y is equal to 70. Or what I like to do is, as soon as I know a single angle in a picture, in fact, this time I know two angles, I like to just fill in all the angles. Well, vertical angles are congruent, so this is 70. Vertical angles are congruent, this is 70. And I find filling in all the values first saves me the trouble later if I have to go back. And so here, 2y is 70. Yup. So, dividing by 2, we get y is 35 degrees. Okay. Oh, and this x was in degrees. Perfect. If you left out the degrees, I wouldn't take off points. Okay, and the rest do the same. Again, strategy-wise, I would like to identify things with the same variable and say those add up to 180 first. Over in this picture, again, I would prefer to find that the y's add up to 180 and the x's add up to 180. And those would be my single equation with single variables that I would use. Okay, so I'm going to switch over IXL really quick and just do some vocab. Had it all loaded. All right. So which angle is adjacent to angle 2? Well, we only have one option. That's 1. Okay, which angle is vertical to C? So I'm going to pull out my pen. CED, the only angle vertical with that is AEB, or you could name it backwards, BEA. So AEB, there we go. So other than itself, which angle is congruent to angle 3? Well, here's angle 3. The only angle we know right now is congruent to angle 3 without more information in the picture is its vertical angle. So if I just extend this side, and I extend this side, then the vertical angle to this one is this one. And you just ignore this other line that was there to distract. Okay, so just extend one side of angle 3 and extend the other side of angle 3. And so 6 is the opposite one. So what is an angle that is supplementary to angle 1? So here's angle 1. Oops. Oh, it's having a hard time drawing. So angle 1 right here, supplementary. So that would be right here. These make a linear pair. Oh, can't do it. So angle 5 is one. Angle 2 is another one. So, yeah, what is in angle? Because they know there's 2 answers. So they'd take 2 or 5 here. Which angle is complementary to 4? So see, I see a 90 degrees here. So that means there's a 90, there's a 90, there's a 90, and there's a 90. And it says which is complementary to angle 4. So one of them is angle 5. And another one, since vertical angles are congruent, this is the same as angle 4. So actually, we also know that angle 2 must be complementary because angle 1 is the same as angle 4. So 2 or 5. Oh, and they didn't use 5. They used 2. They went for the harder one. I like it. So angle 2 is also complementary. Okay. What is an angle adjacent to EGF? Okay, so E to G. Whoops, you got to get out of this. So E to G to F. So adjacent to this one. Oh, there's a bajillion possibilities. We could go with FG almost anything. FGA would work. FGB would work. FGC would work, or you could go on the other side. You could go EGD, EGC, etc., etc. Let's do EGD. There we go. We'll do one last one in here. So which angles are vertical to BFC? Well, they're tricking you there with plural, unless they named it twice. There's only ever one vertical angle because where 2 lines meet, vertical to this angle, there's only one thing opposite from it. They might name it 2 or 3 different things, but there's only one. It's this angle right here. So let's look at our picture, BFC. So BFC, so the only angle vertical to that one is extend to the side, extend the side. It's this angle right here. So it's DFE or EFD. So DFE, and there's no EFD, so that's it. Okay, yeah, so we're done with that one. So let's go over to one last one. That was C3. Let's do C4. So here's actually solving with that. What's the value of U? I see there's a, oh, I got to pull up my pen. I see there's a right angle here. So if this is 90 and we have 35, then U is just 90 minus 35, or 65. Ha! Classic. Forgot to carry the 1. So that was 55. That was my mistake. Correct setup, wrong execution. Good times. Okay, what's the value of B? Oh, well, these are just vertical angles. So we know that these must be congruent. So we know that this is 52 also. Let's see, what's the value of G? So you guys get the point here. Just to show you, so since these are, oh, my pen is not working on the picture. Well, since those two add up to 180, we can go 180 minus 154, and what we end up getting is 26. All right. I hope you enjoyed that video, you guys. Good luck.